Okay, good morning. I'm Jacopo Cassandro from Polytechnic di Milano. This is a research that we develop in collaboration with other colleagues from University of Florence and then Bochum University, Ruhr University of Bochum. And it's regarding the challenges and opportunities of IFC2x3. There's also a first challenges in the name. Just starting from a brief introduction. As we know now, building information modeling has evolved far beyond geometric modeling throughout the entire asset life cycle, starting from the design until also the deconstruction phase. And it increasingly relies on heterogeneous information coming from external database into a digital twins, cloud platform, real-time data streams, and so on. As this workflow become more data-centric, the amount diversity and complexity at the end of information continuously increase. And this evolution raises an important question. Are the current IFC standard at the end able to support these new requirements in our sector? To answer, or just to try to answer to this question, we tried to do this first evaluation that we have in collaboration with these colleagues, starting to understand if we need a new IFC version, if we need to evolve in something new. IFC has been widely adapted into our sector at the end, but there's also some current limitation now in the current version. The IFC2.3 and IFC4 or IFC4.3 is based on a monolithic architecture. It's file-based. Exchange, there's limited external integration if we want to also integrate other information. It's a static model at the end and is a geometric-centric workflow. We have a lot of also extension that we can do, and we will see also other presentation later regarding cost, time, and so on. The gap between current capabilities and emerging industry needs is exactly the motivation behind probably the development of this IFC5 and IFCX, and we saw also during the previous session, the fishbowl session that we discussed a little bit if IFC5 is a bad idea or a good idea. I don't have any answer to that, but yeah, we can discuss about that. And starting from this concept, we just identified these two research questions, investigating in the end the current limitation of the current version, and then the emerging concept of IFC5 to address this limitation and try to identify new possibility, new challenges. We developed, and to answer to this question, we developed this methodology starting from our background, from the background of the entire co-authors, and then we evaluated 4 representative life cycle phases: the design, more or less regarding cost and time management, the construction state and health safety management, the operational and maintenance, and then the circular deconstruction. We starting from an analysis of the state of the art, and then moving to the definition of these shared functional requirements that recur across all these phases. And finally, we use these requirements as common evaluation criteria to compare the different versions, starting from the IFC2.3, coming to the IFC4, and then the emerging IFC5 concept. The 5 shared functional requirements that we identified are this one that we can see in the slide. These requirements cover the ability to extend the data model, integrate external information that we have in external dataset, support dynamic and real-time application, exchange at the end data efficiently in web environments, and then provide geometry suitable for high-performance visualization. Together, these 5 requirements represent the key capabilities that modern open standards should provide to support data-centric workflow. Starting from the first requirement, that is data model extensibility, which refers to the ability of the schema to evolve while supporting new concepts and life cycle specific information. We can see that the current version of IFC are limited in terms of extensibility because of its monolithic architecture. And if we want to increase something to this standard, we have to wait a lot of time because we have to just discuss in the ISO group and then try to understand if it's needed or not this new concept, or we can add some custom property set or custom information. On the other side, IFC5 is, or IFCX is modular and then extensible. Is based on this extensible architecture and probably allow independent evolution of domain-specific modules. Moving to the second requirements, that is the ability to integrate IFC model with external data sources. Current version of IFC are mainly relies on global unique identifier, classification, file references, and these allow dataset to be connected, but only through these identifiers. And this results also on a week of semantic interoperability at the end and limited synchronization. IFC5 probably with this new format, file format JSON based on JSON, and then also some linked data principle. There's also some discussion yesterday in another presentation. We have something new possibility for increase the interoperability with this heterogeneous information, such as database, IoT platform, digital twin services, and so on. The third requirement that we evaluate is the ability at the end to support time-aware and real-time application, which becoming fundamental at the end for our sector in the digital twins and lifecycle management. As we know, IFC2.3 and IFC4 is a little bit static, no, in these terms. It is probably a planning-oriented model. It can represent schedules, but it cannot natively handle dynamic events into the standard. And IFC5 propose an event-based and time-aware architecture and making possible to represent evolving asset states and better probably support in this digital twin workflow. The third requirement focus on web-friendly data exchange, which is essential for cloud-based collaboration and distributed application. The current version is file-based with step file exchange formats, and IFC5 takes a different approach by introducing these web encoding such as JSON, or then also some also the APIs and something like that is more oriented into this data exchange and for this web environment. However, these benefits also require standardized interfaces and strong governance across the distributed services. The last requirement that we evaluate is the performance-oriented geometry representation. We know that the current version is really oriented on this part. They also develop also a new concept in the IFC4 for the geometrical representation and something like that. And IFC5 take completely different approach by decoupling authoritative semantic from visualization-oriented geometry, and also they align also some concept with the USD criteria and standard, and this probably enable high performance rendering while preserving also the semantic information contained in the IFC model. Just to conclude at the end, looking across all the 5 requirements, at the end, IFC5 is not simply an incremental evolution of the IFC4, that is the latest version and official version that we have, but is a genuine architectural shift at the end toward a modular, probably a data-centric and web-native information management. This opens important opportunities, but also these benefits also introduce a lot of new challenges because, okay, IFC5 is a standard or not, and in other words, IFC5 probably does not eliminate complexity. It just trying to redistribute it in some other in some other way. Just to conclude this comparative analysis, we can see that, okay, the current version are monolithic, file-based architecture, and probably IFC5 is more a modular architecture and web-native architecture, and some limitation regarding this work is only qualitative assessment based on our background. There's no real-world implementation or validation, and it's also limited because we don't evaluate any type of regulatory or other organizational aspect. And as future developments, we want to evaluate the quantitative evaluation of these IFC-X or 5 capabilities and validate it also this new format, this new standard, if we can call it, with a real-world case study. Thank you for your attention.